Welcome back, life science students, to week 2, day 2 of our virtual life science lessons. I'm Phyllis Wilson, science teacher at Albert Hill Middle School, and let's go ahead and dive into LS6A. I'm happy that you came back to learn some life science with me. All right, so on Monday, we began our engaging part of our 5 E's, and today we're going to be getting that thorough explanation and doing a little extension. Before we get started, you can go ahead and take out your life science student workbook and your See, Think, and Wonder sheet. This should be filled, this blue section here, with things that you've already typed up based on what we watched on Monday, those 2 videos and that picture that we looked at. So let's talk about that as we look over it, see if the things that I'm mentioning are things that you also mentioned, and also look for things that you might have thought that might be a little bit incorrect. And if you see them there, you can just go ahead and put a star by it so to make sure that you understand, okay, this is something I thought, but now I'm learning it's a little bit different. Okay, so the first thing that we looked at was our condensation video. We saw a glass of water with ice in it. We saw the ice melting. And then on the outside of the glass, you might have seen it start to frost. And then you saw liquid forming on the side of the glass as well as on the table. What you might have thought is that that water on the outside of the glass came from inside of the glass. And that actually isn't true. What happened was there was water in the air as a liquid. I'm sorry, water in the air as a gas. And as that cold glass was there, it started to cool down that water that was a gas. And it made it get, the atoms get closer together. And then that gas became a liquid. And that is the condensation that we saw on the glass and on the table. All right. The lightning video. Hopefully you should have noticed that lightning is important because it helps give nitrogen to plants, and plants need nitrogen. You should have also heard in the video that nitrogen can come from bacteria in the soil. And then hopefully it made you wonder, how does that happen? How does lightning make nitrogen? How do bacteria make nitrogen? Those are some things that hopefully you started to think about. All right. The third thing that you did was looked at this ecosphere, this 50-year-old ecosphere, and inside of it, you should see that there's a plant that's growing so well. It's bright and green. It has some soil here. And the fact that the plant isn't dying should have hopefully made you start thinking, how is this plant getting the things that it needs in this sealed jar? How is it getting the water that it needs? How is it getting the carbon dioxide that it needs? How is it getting that from this jar when it's sealed off and it hasn't been watered in over 50 years? That's something you should have wondered about. All right. The other activity from Monday was this cloud in a jar lab. I hope you got the chance to do it at home. I think it was pretty cool. And what you should have noticed happening in the jar was that the aerosol, as it cooled down because of the ice, began to have water particles that surrounded it, and it turned that aerosol or the water that was a gas in the jar into a liquid. And then as you lifted that lid, you could see the fog or that condensation coming out of the jar. All right. So look back at your life science student workbook. Look at what you put there. The things that you saw. Hopefully you saw a lot of things like I did. The things that you thought. Are any of them inaccurate? If so, you can go ahead, like I said, put a little star by them or scratch those off. And then the things that you wondered, go ahead and circle those. Have I answered any of those questions? If not, then hopefully by the end of this video, you will have those things addressed. All right. So another thing that we had were those 3 pictures, the unicycle, the bicycle, and the recycling symbol. So the unicycle, if you look at it, it has 1 wheel that has no beginning and no end. The bicycle, bi means 2, has 2 wheels, once again, no beginning and no end, that go round and round when you ride them. And then the last picture, the recycling symbol, has arrows, but you can't really tell where they start and where they stop. They're just kind of going around and around. And that is what they have in common. They all include the word cycle or the suffix cycle, which the word cycle means that something repeats over and over again, kind of like a circle. It has no distinct beginning and no distinct end because it just flows from one step to the other. And in science, in nature, in ecosystems, we have cycles, biochemical cycles that show how different elements and things cycle through our ecosystem. There's no real start to them, no real end, but they keep flowing around and around. And that is what we're going to learn about today in LS68 with this explanation: the water cycle, the carbon cycle, and the nitrogen cycle. Those are three elements that technically what we have on the earth today is the same water that was here millions of years ago, the same carbon and the same nitrogen. How does it work? Let's talk about it. We'll start with the water cycle. In fifth grade, you begin to learn about the water cycle. And the water cycle tells us how water moves from the air in the atmosphere back to the surface of the earth, on the ground, in rivers and oceans, and also how it moves through living organisms like the trees that you see here, or even animals and other organisms like mushrooms. How water moves through all these things and goes back and forth over and over again. We also call the water cycle the hydrologic cycle because hydro means water. So it has 5 main steps. You can kind of see them here in this picture, and we're going to talk about them together. These are the 5 steps that we focus on in 7th grade science. Okay, so I'm going to just pick a place to start, and I'm starting with evaporation. If you look at that, it's when water changes from a liquid to a gas. And another word for a gas is a vapor. And when that happens, it's going to rise into the atmosphere. And this happens as water is heated up. So we have the sun shining. As the sun shines on this water here, it is going to heat that water up, change it from a liquid here into a gas, and hot air rises. So as that liquid heats up to a gas, it rises up, up, up into the atmosphere up here. And we call that evaporation, when the water as a liquid becomes a vapor or a gas. All right, another way that water gets into the atmosphere is called transpiration. So transpiration is when the water vapor rises, similar to evaporation, but it's going to rise off the surface of plants. So in this picture, you can see transpiration here with the trees. So this is when the trees or the grass or the trees over here are all going to have water vapor come off the surface of them. All right, so how do I remember this? Okay, as a human, when we work really hard, we perspire. We are sweating when we're perspiring. So when the trees sweat or when water comes off of the trees as a vapor, we call that transpiration. So people perspire and trees transpire. So this is what's happening here with our transpiration. And once again, the water is going to become a gas and it's going to rise into the atmosphere. All right. So once all that water vapor, that water as a gas is high up in the atmosphere, it starts to cool down because it's cold up there. And as it cools down, it changes the water from a gas to a liquid. And this is called condensation. And as the water cools and cools, the atoms become closer and closer together. And it goes from a gas to a liquid in the clouds. And we call that condensation. So this is what's happening here. You have the evaporated water, the transpired water as a gas, and it's going to form our clouds. I try to remember the C's of condensation. When I have all those C's on a test question or on a paragraph, then I know it's talking about condensation. So condensation is when water cools It also condenses, which means the atoms become closer together, and it forms the clouds, all part of condensation, all C's. Okay, after the clouds get heavy, okay, the water is going to fall from these clouds as they're full, and it's going to fall in the form of precipitation, okay? If something precipitates, it means it falls out. So the water falls out of the clouds in the form of rain, snow, sleet, or hail. And we're pretty familiar with precipitation. All right. So once all that water falls from the sky, some of it rolls down mountains as runoff, some of it falls directly down. And that is when the water is going to collect or pool together. And we call that accumulation. When the water accumulates or collects, and it can collect under the ground in groundwater, it can collect in streams and rivers, it can also collect in oceans and lakes as well. So that is all called accumulation when the water collects. So those are the five main steps of the water cycle: evaporation, transpiration, condensation, precipitation, and accumulation. You need to know those five. All right. In your science workbook, you have a page that says Cycles Brain Pop Worksheet. And it says use the Brain Pop water cycle video and Miss Wilson's explain video to fill in the following chart. So you should have that chart open. You already should be able to fill in some of the information in that chart based on what we just discussed. And so let's go ahead and take a peek at that really quickly, that chart in your workbook. Oh, I'm on the wrong page. All right, so here's that page, Cycles Brain Pop Worksheet. So on this chart, we can see it asks us to describe what happens to the water during each step of the water cycle. What happens during evaporation, precipitation, condensation, transpiration, and accumulation. So you can just type your responses in the light blue boxes. You also need to find 2 reasons why the water cycle is important. And a true or false question, you're going to circle one of the words. The water on the earth today is different from the water that was here 1 billion years ago. So those are the answers you're looking for. And we are going to go ahead and we're going to watch this video. You're going to log in, RPS Life Science and RPS for you. I'm sorry, for me to use. And it should come right up for you just like this. And let's go ahead and take a peek.
Water solution, flood tubes 1 and 2, incoming. Don't make fun of my hobbies. Dear Tim and Moby, where does all the water in rain come from? Signed, Stephen. Well, there's always a certain amount of water vapor in the atmosphere. It comes from the Earth's surface water, like oceans, rivers, and lakes. Water from these sources evaporates, changing from a liquid to a gas. Down here on the ground, you usually can't see the water vapor that's all around us. But higher up in the atmosphere, gaseous water cools down and condenses into clouds. When water molecules in clouds collect into big enough drops, they fall on us as rain. Or as snow, sleet, or hail, depending on the temperature. Water is constantly cycling from land to air and back again. As you might have guessed, this process is known as the water cycle. Scientists study it because water is such an important part of the ecosystem. Every living thing on the planet depends on a clean supply of water. Well, you can think of the water cycle as the Earth's circulatory system. Just like there's a fixed amount of blood circulating through your body, there's a fixed amount of water cycling around, over, and inside our planet. All that water is known as the hydrosphere. The sun is the heart that pumps water around the hydrosphere. Its heat energy breaks the bonds between water molecules, causing them to evaporate from oceans, lakes, rivers, even plants. You're right, water returns to the earth through precipitation, also known as rain, snow, sleet, and hail. Sometimes, water flows across the surface of the earth as something called runoff. Runoff adds to the flow of streams and rivers. Or water can soak into the ground in a process called infiltration. Water that's infiltrated the ground is called groundwater. It can stay beneath the surface anywhere from a few days to thousands of years. This groundwater feeds wetlands, lakes, and streams, and supplies us with water for drinking, farming, and lots of other stuff. The water cycle's been going on for billions of years, circulating the same supply of water over and over and over again. The same exact water molecule a dinosaur drank from a pond 100 million years ago could be inside the glass of water you drink today. And check this out, even though water is constantly moving through the hydrosphere, the amount in any one part of the cycle never changes. Well, take the ocean. It contains about 97% of all the water in the hydrosphere. It loses a huge amount to evaporation every day, but it makes up that same amount from groundwater, precipitation, and rivers. So, the amount of water in the atmosphere and the amount of water on the Earth's surface stays perfectly balanced all the time. It's kind of like a big, beautiful machine. No, not as beautiful as you.
Oh, Tim and Moby cracked me up. Okay, so that was that. We watched the video, and between that and the notes that we already took, you should be able to go in and describe what happens to water during the steps. Evaporation, what happens, precipitation, condensation, transpiration, and accumulation. And if it helps you, you can look at the picture as well when you type. You also can give the reasons why the water cycle is important. That really came from the video. And then you can do your true or false question by circling the correct word. All right. Once you're done with that, the next thing is to continue to the next cycle. All right. We know about the